We're on topic 20, page 111, and we're going to be looking at these two examples, number 4 and number 5, and then we're going to analyze how we can tell how many roots there are and what kind of roots there are to the solution of a quadratic equation by examining the discriminant b squared minus 4ac. So let's start with problem number 4, and on the third topic here on the discriminant, we're going to bring back each one of these problems and make it one of our categories. So first of all, let's look at this equation here, 2x squared plus 5x minus 3 equals 0. In order to solve what values of x that make this equal to 0, we use the quadratic formula. Here's the quadratic formula, and in this case, a is the coefficient of x squared, and it's 2. B is the coefficient of x, which is 5, and c is minus 3. So we plug these into this equation right here, a, b, and c, and we come out with minus b, minus 5, plus or minus b squared, minus 4. A is 2, right here, and c is minus 3. So when we calculate this part over here, minus 4 times 2 times minus 3 comes out to 24. So 25 and 24 are 49, and 49 is a perfect square. So we are left with minus 5 plus or minus the square root of 49 over 2a, which is 2 times 2, 4. And so when we solve this and we take the square root of 49, we get 7 minus 5. One of the solutions is minus 5 plus 7 over 4. The other solution is minus 5 minus 7 over 4. So minus 5 plus 7 over 4 gives us plus 2 over 4, which reduces to 1 over 2. And minus 5 minus 7 over 4 becomes minus 12 over 4, which is minus 3. So we have two solutions, a half and minus 3. So if we check the answer and we substitute x equals a half and substitute it into this equation, we have 2x squared, where x is a half, squared, plus 5x, 5 times a half, minus 3. So this is just arithmetic. A half squared is a quarter, and 2 times a quarter is a half. This 5 times a half is 5 halves minus 3. So if we add a half plus 5 halves, we get 6 halves, which is 3. 3 minus 3 is 0. So the left side equals 0. The right side is 0, so the left side equals the right side. Go over here. Okay, the right side is 0. Now, the other solution that we have is that x equals minus 3. We put that into the equation, and we get 2 times, instead of x squared, we're going to write minus 3 squared plus 5x. Replace the x with minus 3, and we get minus 3. Well, minus 3 squared is 9. 2 times 9 is 18. Minus 15. And minus 3. So 18 minus 15 minus 3 becomes 0. The right side is 0. The left side equals the right side. Now, we could have also solved this by factoring. So we could have factored this as 2x minus 1, x plus 3. The first times the first gives us 2x squared. The last, minus 1 times plus 3 would give us minus 3. The outer is 6x plus 6x, and the inner is minus 1x, and that gives us the middle term of 5x using the FOIL So one of the solutions is 2x minus 1 equals 0, in which case x equals a half. And if x plus 3 equals 0, x equals minus 3. So the same solutions, a half and minus 3, can be obtained in two ways. You have two choices. You can do the factoring, or you can use the quadratic equation. Now, if you see the factors right away, or you're not sure what the factors are, then you can use the quadratic equation, because the quadratic equation will always give you the right answer no matter what, even if you don't know how to factor. The problem with the quadratic equation is, I think you will agree, that it is a more lengthy procedure. It's a more time-consuming procedure. So you should always see if you can factor first, because that is, generally speaking, a quicker solution. So go to example 5, x squared minus 12x plus 36. Here again, we're going to use the quadratic. Here's the quadratic equation right here. Should know this off by heart. In this case, a is 1. It's the coefficient of x squared. B is minus 12. And C is 36. So here we have it. A is 1, B is minus 12, and C is 36. So we put that into the equation. We get minus 12 plus B squared, which is minus 12 squared, minus 4 times 1 times 36. A is 1 and C is 36. Now, there's a number 2 missing here from the manual. So put as a correction, put the number 2 here. It does appear over here, but it's somehow missing here. So 144 minus 144 is 0. So the solutions are 12 plus or minus 0 over 2. And so there's one answer. 12 over 2 is 6. Since we have the 12 plus 0 and the 12 minus 0, we say there's a multiplicity of 2. But there's really only one solution, x equals 6. So when we check x equals 6 into the original equation, 6 squared minus 12 times 6 plus 36. 6 squared is 36. 12 times 6 is 72, and there's a minus there, plus 36. So 36 plus 36 is 72, minus 72 is 0. The right side is 0, and the left side equals the right side. So we check the solution. You could have also solved this, could be solved by factoring. There should be equals 0 here, but here we put it in. So we could see that x times x gives us x squared. The inner and the outer are both minus 6x, and when we sum them, we get minus 12x. And the last term, minus 6 times minus 6 is plus 36. So x equals 6 equals the solution for this. Now, the last part on page 111 is a discussion of the discriminant. And what we do is we're going to look at different examples, and we're going to categorize them as to one of 4 categories that we have down here that are on the bottom of this page. So we're going to look at each one of these cases, try to give an example. And here, b squared, what we're going to do is calculate b squared minus 4ac. So let's go back and do it for this case here, which was example 4. And by the way, this number here, there's a correction here. This should be 5 and 4, not 6. There is no example 6. And so we're looking at example 5 and 4. And the 2 examples are given here. Now, in this case, when we calculate the discriminant b squared minus 4ac for this case over here, we get 5 squared, which is b squared minus 4ac A is 2 and C is minus 3. We did this before. It's 49, and 49 is a perfect square. If the solution of b squared minus 4ac is 49, there are two rational solutions. If, on the other hand, b squared minus 4ac, as in this case, comes out to be, this is minus 12 squared minus 4 times 1 times 36, we did that before, is 0. There's only one irrational solution. So if it's a perfect square, we know there's two rational solutions. If it equals 0, it's one rational solution. So if you look at the solutions to this is a half, minus 3, and 6 are all rational numbers. And rational numbers can be expressed as a over b, where a and b are integers. That means that a and b have to be whole counting numbers. So really, here we've got 1 over 2, a over b, 1 over 2. Here, the denominator, we can write this as minus 3 over 1, a over b. And this is 6 over 1. So you can always write it. Rational means a ratio of integers. However, the denominator can't be 0. B can never be 0. So what are the characteristics of rational numbers? They terminate. Means that, you know, it's just 6. There's no number afterwards. Minus 3, it terminates. A half is 2. Now they can always, there can be repetition, okay? So you could have, for example, 2 over 3 is 0.66666, 0.666. So you could have numbers that either terminate or repeat, and they are rational numbers. So here we have case 1, which case 1 we're going to see where b squared minus 4ac is 0. That's this one right over here. That's a case 1. Okay. And where b squared minus 4ac is a perfect square, then we have two rational solutions. And that is the other case right over here, 2x squared plus 5x minus 3. This is a perfect square, and there's two rational solutions. Here was only one solution. Here there's two solutions, and they can be expressed as ratios. So what are the other cases? Case 3 is where you get b squared minus 4ac is positive, but it doesn't equal a perfect square. So b squared minus 4ac is positive, but it does not equal a perfect square. Over here, it's when it's a perfect square, you get two rationals. When it's 0, you get one. So what happens at b squared minus 4ac is positive, but not a perfect square. We get two irrational solutions. And first of all, what is an irrational number? They neither terminate nor do they repeat. So go down here again. Page, excuse me. So irrational numbers neither terminate nor repeat. So if you take the square root of 5, you get 2.323679. It keeps on going. There's no exact value for the square root of 5, and so it's an irrational number. It cannot be written as a ratio of integers. An example of a quadratic equation that would be x minus root 2, x minus 5. This would give the case 3 where b squared minus 4ac would be greater than 0, but would not be a perfect square, and we would have two irrational numbers. As you know, if x minus 2 equals 0, x equals 1.414, and it keeps on going. So Just as the root of 5 is an irrational number, the root of 2 doesn't terminate, doesn't repeat, and so it is also irrational. So the last case is a case we discussed previously, b squared minus 4ac. The discriminant is less than 0, it's or negative, and this was a case that we did, page 110, example 2. Here's the problem. And when you work out with the quadratic, you can see b squared minus 4ac comes out to a negative number. And so there are no real solutions for this case. So let's review the 4 categories. If b squared minus 4ac, we're looking for the solutions to the quadratic equation. Solutions represent the x value where y equals ax squared plus bx plus c equals 0. What are the valid values for x? If b squared minus 4ac equals 0, there's only going to be one value of x that's going to work. If you have case 2 where it's a perfect square, b squared minus 4ac is 1, 4, 9, 16, 25, 36, etc., etc. We're going to see 2 irrational solutions. If it's b squared minus 4ac is positive and it doesn't equal 0, and it doesn't equal 1, and it doesn't equal 4, and doesn't equal 9, doesn't equal 16, 25, it doesn't equal a perfect square, we're going to have 2 irrational solutions. If b squared minus 4ac is negative, we're not going to have an x value that will work. Okay, so there's going to be no x value that works. So this completes our discussion of page 1.